So real quick, we're going to show you guys what happens when you drop in a strong acid. So a strong acid, like hydrochloric acid, drop it in. I'm going to put it as like a brick, and I'm not drawing the structures out. I'm going to keep this simple. So we're going to got 5 waters in here. Drop it in. Let's say I drop 1 HCl at a time. Dissociation. H plus, Cl negative. That's the first one. So I drop one in, dissociates. Drop another one in. Dissociation. Perfect. Drop a third one in. Dissociation. So strong acids dissociate 100%. And eventually what you need to understand is these H's actually form an attraction with H2O to form something called hydronium H3O. I don't need you stressing over why. I really don't need you worrying about that. I'm just telling you right now, they form something called H3O. So strong acids dissociate completely. Don't worry about why, don't ask, don't, just chill. Just know they dissociate completely in water. And the negative ion stays by itself. So let's take a look at a weaker acid like hydrofluoric acid. One of the reasons why hydrofluoric acid is weaker than hydrochloric acid is because fluorine has a smaller radius, greater force of attraction, therefore it wants to hold on to its electron stronger, and it doesn't want to dissociate as much. Again, don't stress too much over that. Just let's keep it simple. Strong acids dissociate 100%, weak acids dissociate slightly. So let's once again put in 5 water molecules, just for simplicity. There's 5 water molecules. So let's put in the weak. We'll put in 3 hydrofluoric acids. And I'm not saying 3 moles, 3. I know that's impossible, but we're just taking it easy. Let's put in 3 HFs. Drop in the first one. Did you ever hear the Price is Right thing? Like that noise on the Price is Right, like you lose. Drop it in, no dissociation. I mean, it'll dissolve because it's polar, but it doesn't dissociate. So the pH doesn't shift that much. Drop it again. Okay, ding, 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 ding. This dissociates. Here's your ion right here. It's ready to form a H3O. This goes to here. This goes by itself. Drop in a third one. Lose. Dissolves but does not dissociate. So therefore the weak acid pH does not shift as much. Strong acid, big pH shift. pH changes. 100% dissociation. Okay? Let's go. Let's now look at bases. Same idea. Hold on. I think it's wrong. Hold on. So let's look at a strong base first. Hold on. All right. So let's look at a strong base like sodium hydroxide. Okay. So now we're going to put in 5 waters again. Okay. And now, okay, we're now going to take a look at sodium. So I'm going to drop 3 in. If it's strong, you're going to see a significant pH shift upward. Why? Because you're going to form hydroxide. Drop in. Ding, 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 ding. I'm not going to show how the IMFs, okay? I'm not getting, you know that. All right? I don't have time for all that. It dissociates. We have hydroxide. pH goes up. Drop it again. A second one. Ding, 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 ding. Full dissociation. Drop in again. Ding, 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 ding. Full 100% dissociation. You notice that 100% dissociation, big, significant change in pH. Okay? So that is a strong base. Let's get a weak base. Let's see. Let's go with, let's see, which one do I want to go with? Let's go with NH3. Ammonia. NH3, huh? So let's draw 5 waters. Now, NH3. You know the Lewis structure. Can you see that? Here, I'll move that up. You know it's slightly polar this way because there's excess negativity here, positivity here, so it can dissolve. But can it dissociate well? Not well, if at all. So NH3 comes in, it dissolves because it's polar, but does not dissociate. So not a big change in pH, if at all. Here's another one. No dissociation. And a third one. No dissociation. Okay? Very little dissociation, if at all. Again, so all I need you to know is this. Strong bases show significant change in pH. Strong acids dissociate, just like strong bases. Strong shift in pH. They form those ions you need to cause that shift in pH. Weak acids and weak bases don't give off many dissociated ions to get that shift in pH. So I'm going to leave you with a teaser for tomorrow. So let's say I've got this. And I'm going to draw the H3Os, meaning we've got, actually no, I'll be easy. Let's throw our sodium hydroxide in there. So let's say I've got 5, let's say I've got 3 waters. 3 waters. And let's say I've got sodium hydroxide, which is fully dissociated. Three of those, and I'm going to draw 3 Na positives. See that right there? So then right now we've got a high pH. I need to get it to neutralize. So if I want to get it to neutralize, what should I add? Should I add something that does dissociate? Let's do the acid. Or one that doesn't. Based off what I said before, what happens when I drop this in, and what happens when I drop this in. And what happens, and I want you to think, take a look at what you're working with. If you drop this in, what forms, and then what could form as a result? Because right now you've got water, you've got ions, but now if this dissociates, what could form? And how could would that cause a neutralization? You should have watched the first video on the FET that I just did a few minutes ago, and that would give you an idea. And that's what we're going to talk about tomorrow. I want you to predict what you think would happen. Okay? This is the way we can shift pH, and I'll show you everything tomorrow in tomorrow's video. Okay? That's it. So again, don't overthink this. Just understand about dissociation. Strong acids and bases dissociate easily. Weak ones do not. Do not worry about why some are weak or some are strong. That's higher level chemistry, no offense. Do not worry about how we get hydronium. Just know it's because of the dissociation. Again, that goes way above our level, even honors chem level. Again, I just want you to understand, this is a way to take what we learned with ionic and covalent compounds, how things dissolve to another level. Okay? All right, so that's going to be big. That's the end of it. That'll be tomorrow. Okay? Hope you took good notes. That's it.